and overlays of 2 inches or less, which greatly reduces flowback and facilitates obtaining required critical elevations. The jet spray process preserves and enhances the marsh habitat's ecological functions while eliminating berms, containment ponds, pipelines, and anchors required by the more traditional methods of mechanical and hydraulic dredging. Dr. Pace Wilbur, a marine biologist at the U.S. Corps of Engineers Waterways Experiment Station in Vicksburg, Mississippi, recently completed a paper on the long-term environmental effects of thin-layer disposal on a saltwater marsh. His paper covers the results of a jet spray project completed in 1982 at the Lake Landing Canal, Hyde County, North Carolina.
Well, it's been becoming more and more difficult to dredge projects that are surrounded by open water or marshes because there is no place that is generally believed to be environmentally acceptable for placing the dredged material. Jet spray has an opportunity to reduce, in some cases, eliminate the 3 major impacts from placing a dredged material in a marsh. The first one, as far as suffocating the material or killing the material, that, in my opinion, is pretty much unavoidable. Although in a typical dredging technique, you have dredged material that's killing the plants. In a thin layer disposal situation, because of the large amounts of water involved, the water can sometimes kill the plants. But it's not necessarily a bad situation because the below ground biomass can still stay in relatively good health and then emerge relatively quickly. In terms of isolating off-site wetlands, thin layer disposal affords you an opportunity to more precisely control where you're placing the dredged material, so you can avoid putting the stuff where you don't want it, where it could block the sheet flow of water to an off-site wetland. The other impact with changing the soil chemistry or the elevation or some other physical characteristic, by placing less dredged material in the marsh, you're basically providing less of an opportunity to actually cause a change that could lead to a vegetation change in the community.
As was the case in the 1982 North Carolina project, jet spray can be adapted to any conventional cutterhead suction dredge. With Hyde County, North Carolina being one of the East Coast's most productive shrimp nurseries, it was essential that jet spray's environmentally sound technology be utilized to maintenance dredge a canal with over 100 years of silt buildup. The material was sprayed a distance of up to 150 feet over an existing berm and trees and onto the saltwater marsh in uniform 5-centimeter thin overlays.
Last year, working in collaboration with 2 folks from East Carolina University, we returned to this site, staked out the original dredge material placement area and several reference areas, and collected various types of vegetative and faunal data to compare the dredge material disposal area to the reference areas. If you looked at the disposal areas just by themselves without making a direct comparison to the reference areas, they did have a healthy stand of vegetation there. So the areas, they were not equal to the reference areas, but they were not bad. The most quantitative data we have is on the infaunal community, and in terms of the infaunal community, there was no difference between the reference areas and the disposal areas. Infauna, it kind of, as the name implies, are the really small animals that live in between the sand grains and the silt grains inside the marsh. So those are really small worms, really small insect larvae, some really small bivalves and things like that. There basically was no generalizable difference between the disposal areas and the reference areas in terms of that infaunal community. We have some qualitative data on fish and crabs that use the marsh, and again, there was no easily generalized difference between the reference areas and the disposal areas.
More recently, jet spray is being utilized in several marsh reclamation and reinvigoration projects on the sensitive Louisiana coastlines. The Mississippi River Delta is the nursery for approximately 70% of the fish in the Gulf of Mexico. It is the United States' largest bird rookery and fur source, and contains over 41% of the wetlands in the lower 48 states. This priceless resource is disappearing at the alarming rate of some 60 square miles per year due to human intervention, subsidence, and sea level risings. Dr. Donald R. Cahoon, an ecologist with the U.S. Fisheries and Wildlife Service's National Research Center, has studied the importance of marshland habitat.
Wetlands are among the most highly productive ecosystems in the world because they're located between the uplands on one side and the ocean on the other, and they get benefits, subsidies, materials, and energy from both sides, and therefore they rank right up there with the highest productivity of any system in the world. So there's a large production component. We get fish and shellfish and wildlife and waterfowl. They're highly productive systems, and we as humans draw a lot from them in terms of food, habitat, storm protection. When storms hit the coast, the extensive wetland in front of you can help diminish the power and strength of that storm. They help to recycle water, the water cycle, recharge groundwater. Besides the basic aesthetics, there's a tremendous amount of value associated with wetlands. So when we lose wetlands at the rate that we're losing in Louisiana, we as a society are losing a tremendous natural resource. And we're seeing that resource base diminish right now, right before our very eyes.
The Mississippi Delta restoration is seen by many as the most important worldwide wetlands preservation effort of the next century. Leading the way in this effort are two freshwater diversion demonstration projects in Plaquemines Parish below New Orleans. These projects are designed to divert sediment-laden fresh Mississippi River water into the Delta Marsh at the rate of 4,400 cubic feet per second. Prescott Follett, the design engineer on this project, called for the use of several large siphon tubes running from the Mississippi River into radiating outfall channels dredged with jet spray technology.
The project at West Point Lahash and at La Recite consists of a large battery of siphons, 6-foot diameter pipes, eight of these in each location. The idea is to bring fresh water out of the Mississippi River and also some silt and deposit it out into the marshes of the west bank of Plaquemines Parish. The idea of a siphon is to come over the top of the levee. One end is submerged in the river at below low water line, and then the other side is eventually is brought out to a pond, a discharge pond. The idea of the pond is to settle out the heavy sediments that are in the river. The light silt will stay in suspension, and instead of having to fight its way through the marsh, we've dug some small channels radiating out from this pond. The small radial channels have been dug with a unique piece of equipment that does not destroy the marsh with the spoil banks. With this method, it's sprayed out over a long distance and only builds up maybe half an inch of material over a large area on both sides. The jet spray is more like a big fire hose, and the dredge chews up the mud into small particles so it can go out through the hose. So it's like a spray that can rotate to distribute the material over the marsh. With the jet spray type of dredge going in, and we're able to economically dredge into the wetlands in a certain pattern that will help the sheet flow out into the marsh and give an even distribution of the fresh water rather than keeping it in a single channel and having no outlet. And this has another effect that I think is good to know about, is that The material that's sprayed out acts like a fertilizer for the marsh. It's ground up organic material. It's been aerated and it's in thin layers so that the vegetation that receives this material, rain and so forth, will bring the material down to the base, and it actually seems to stimulate the growth of the immediate area. In the future, there are several locations we're looking at for additional water diversions. In those cases, we would undoubtedly seriously consider using the jet spray again.
The planned increase in marsh size for these two projects in Plaquemines Parish is 17,400 acres, with the project size to triple shortly. These demonstration projects have proved to be a great success, with the results from the first operation meeting and exceeding all goals, especially the rate of sheet flow over the marsh. The future for jet spray lies not only in being able to dredge and maintain canals without adding to the erosion and devastation of the marsh, but to also be used in reinvigorating wetlands and creating new marshlands. Dr. Cahoon has performed extensive research on spray disposal of dredged material in Louisiana wetlands.
Well, the interesting point about jet spray is that it's a suction dredge that will slurry the material as you dredge it up, rather than leave it segregated with the big particles segregated from the small particles. It mixes all the big and small particles together, slurries it all together, shoots it out under high pressure so that you can lay it in a very thin layer. Traditional hydraulic dredging which does not segregate, which allows the materials to segregate, would dump the material in a spot, and the big pieces would stay there and the small pieces would float away, and you would have this you'd have a sorting of sediments and grain sizes that wouldn't allow you to have a natural soil. And jet spray will slurry them together and lay it out in a nice, fine, thin layer across the marsh surface. And the preliminary research that we've done shows that basically you can spray this material onto a marsh surface and not convert the marsh into a upland habitat, but you can maintain an intertidal habitat, a marsh intertidal habitat. The difference between this new jet spray technique and historical methods of stockpiling sediments for marsh creation is that marshes have been built with dredge spoil for last several decades, and they take dredged material, and they dispose of it in a shallow water area, build the area up high enough to support vegetation, and they plant it. But what jet spray will be able to do is actually take dredged material, and spray it out onto a vegetated wetland that's perhaps deteriorating or breaking up or subsiding or sinking out of sight, and spray material back onto the surface of that, and then help it maintain its elevation, help build it back up and keep pace with sea level rise.
Due to jet spray's positive results in thin layer, wide area broadcasting of dredged materials, this process has been formally recognized by the major environmental regulatory agencies, who now often require this disposal method when permitting sensitive projects. With the addition of the jet spray process to any hydraulic dredge, an inexpensive solution to previously environmentally damaging containment or berm spoil can now be achieved. The jet spray process imitates nature's own flood-ebb marsh renewal cycle by creating a similar overlay of residual material that strengthens and fertilizes the marsh and its ecosystems. Jet spray is available through Aztec Development Company and licensed distributors and contractors. For further information on the environmental advantages of jet spray services or equipment, contact Mr. Troy Deal Jr. in Orlando, Florida at 800-432-4745. Jet spray, the environmental solution that converts undesirable dredge spoil into environmentally desirable overlay placements of dredged material.